Hello, welcome to this lecture. We are going to analyze in this lecture how to turn procedures to objects and what are the good advantages of this. The goals for this lecture is to present the idea that objects representing procedures, representing algorithms are really powerful and we want to use them when we need to have complex algorithms. It is basic idea is to take some behavior, to take some procedure and convert it in object, in one or more objects. We are going to explore a basic example and we are going to see how this example, if we start adding variations and if we start adding configurations, start getting bigger and bigger and is not manageable and we need to create objects to represent them. Let's start with our example. If we take any class in Pharo and we send the message print hierarchy, we can see a textual representation of its hierarchy. It has in one side the receiver, the class that we are printing, the superclasses of it, and the subclasses of it. And for each of these classes, we are also printing the instance variables. This is really cool. It allows us to have a nice simple tool that generates a textual representation of our hierarchies. If we see the code that implements this, we see that it's kind of straightforward. We have a print hierarchy in behavior that is the superclass of the class meta object. And we see here that what it's doing is first iterating all the superclasses and printing them, and then doing the same with the subclasses. In this case, delegating in another method. If we see the print subclasses on, this is implemented by doing a new tab in the printing, then putting the name of the class, and then printing the instance variables. This is for the current class that we are printing, and then what it's doing is that it's starting to iterate on all the subclasses and doing this printing in a recursive way. It does some kind of ordering, so we can print the subclasses always in the same order, but basically what it's doing is applying the same procedure to the subclasses. This is really good. It's a good solution because we have this procedure has been split in two methods that are quite simple. We have one method that is responsible for printing the superclasses of the class and one method that is responsible for printing the subclasses of the class. And all the state that is needed by this procedure is passed as arguments. So we have a really clean and nice solution. The problem starts when we start to add new features to this solution and we want to have other requirements. We start seeing the limits of it. What happens if we need to filter some subclasses? In the case of this class, RBLin rule, we will see that has a lot of subclasses. So we want to filter them or we want to show some of them. What happens if we want to show, I don't know, the first 3, the first 4, or none of the subclasses? For example, what happens if we want to decide to print or not the superclasses depending if they are in a package or not? Because, for example, we want to only print the superclasses that are part of our own package and we don't care about printing object or proto-object or any of the classes that are part of the Pharo system. What if we want to print or not instance variables? These are some little examples of possible configurations that we want to do to our hierarchy printer. But now, if we want to do it, we have to add more and more arguments to our method to print. Those arguments also will be passed to the print subclasses on that we have that is doing the procedure for the subclasses. As we see, we can start having an explosion of new arguments that we have to add. Also, we cannot start adding this state as instance variable because the implementation of this printer is directly in behavior. It will affect all the classes in the system. So it's not a good idea, it's not a good solution to add instance variables in all the classes of the system just for printing. Also, it is complicated to configure this printer because if we have a printer that requires 10 new arguments and we just want to use it as before, we are going to pass values to these arguments and know what are the values to pass when we want the default behavior. So what we want to do is turn this procedure into a simple object that we can configure in a simple way. In this case, if we want to configure our printer in the default way, we are going to create it because when we instantiate this printer, it will have the default configuration, and we are going to send the messages only to modify the behavior that we want from it. A more complex idea, this is really simple one. We are going to print the rectangle class, not showing the instance variable, not showing the superclasses, but we can get more and more complex. And for example, saying, okay, we want to print the RV class, not showing the instances, not showing the superclasses. We can send or not this message if we want or not, and then we can pass, for example, one or more or two collections saying which are the classes to exclude and which are the classes that we are limiting on. As we see, we have different ways of configuring our hierarchy printer object because now we have a more flexible element that we can play and do all the tools that we already have seen in this MOOC. Let's see a little of its implementation. We see that it's a really simple object. It has all the state required for executing the procedure. We are going to create it with the instance variables that are required to do the procedure itself. And the most important part is that when we instantiate it, it will come with default values for this, for the default behavior, and then we can have a nice API, very fluid API that we can interact with it to configure it. We can configure it directly saying, okay, class printer, I don't want you to show the instance variables. When we send this message, it will store that in an instance variable, knowing to show or not the state. Or we want to be limited to some specific collection of classes, and we can talk to them. And also we can add all the kind of API that we need for implementing, for example, decorations. If we want to add more tabs between each of the elements, or we want to leave white lines in the middle, all that behavior is implemented in the class hierarchy printer object. Let's see another example. In this case, we are going to talk about a date printer. A date printer is a really nice example of this because we have different formats of printing dates. Even we have different formats that change from language to language, from different ways of printing in French, in English, in Spanish. And also we have different formats that are printed different ways depending on our program. We can have the day and month complete. We can have the day and a short month, or different representation with different separators of the numbers, or different order depending. And the question is, we implement all this behavior in the classic print on colon method that is in date. It will be a little limited. We will have to choose for only one and accepting that the others are not there. Or we will have to have an explosion of different print on methods or the different way of configuring it with arguments. So what we want in this case is to have an object that represents us the date printer and that we can configure in the different formats. This object exists, and we have a really more complex example that is the timestamp format. Is two different ways of representing a timestamp. A timestamp is just a date with the time in the highest precision that we can. So we can represent that in different way. We can print them in different way. And this is the work of the timestamp format. It's basically an implementation of this printing textual representation for a timestamp, and can be also used for parsing. So we can get from a date or a timestamp, we can get the text representation in different format, and from this text representation, we can also parse using the same object, using the same configuration, we can parse a given string. So in this case, we can see that we can pass the timestamp and read it from a string. And also we can format this string and say how it has been printed, this timestamp. It has the two operations, but the important thing is that the timestamp format encapsulates this complex printing, and the timestamp itself, the object timestamp, does not need to know how to be printed. In this case, we can show another example when we configure the timestamp format with a given format for the date, and when we parse the new string, we get the correct time. As we see in this example, we are taking the timestamp format, configuring it, and then using it for one of these operations of parsing a string and obtaining a date, or taking a date or a timestamp and printing it as a string. If we do a little analysis of all this lecture, we have that the idea of creating little objects give us the power because they can be configured. We can modify them to have different internal state to act in different ways. We can have, in this way, all the state that is needed for the procedure, for the computation that we are doing, for the complex algorithm, complex or not, but we have all the state and all the configuration there. We can have nice APIs that we can configure and make the user of this procedure more happy, more easy to read, more flexible, because we are not thinking about adding a lot of arguments to the procedure, but we are configuring object, and the object can have specific initial values that already are useful for most of the situations. And as we have a little object and these objects are independent, we can write beautiful tests on them so we can test if they are working as we want. This idea of turning methods, turning procedures, turning behavior into object is a key point of the command design pattern and the visitor pattern. And this is a really powerful idea. You have to think always, if you want to take your procedures, your actions, and reify them as objects to gain flexibility and to gain the ability to configure and add new features in the future and make it more maintainable.